everyone. This lesson is about differentiation of transcendental functions. This is the continuation. Hold on. This is the continuation of the differentiation of transcendental functions. But this is actually the next topic that we have is about the derivative of trigonometric functions. We're done already with finding the derivative of exponential, logarithmic, trigonometric. Now we're supposed to discuss derivative of inverse trigonometric. But before we go to finding this derivative, let's first discuss how to use or how to do logarithmic differentiation. So what is this logarithmic differentiation actually? This is actually used in differentiating functions which are in complicated form. And to do that, we apply logarithms on both sides before we differentiate. So, if you're going to recall, okay, we solved this kind of problem here, this one. We did solve this problem using chain rule. So, diba, when we solve this one, here, when we solve this one, what we use is to find the derivative. We use here the derivative of product. Can you recall that? So we use UdV, we use UdV plus VdU. So what we did then is to consider that this is U and this is V. And then we use chain rule. So besides this one, we also use chain rule, which is the derivative of U to the N, which is N U to the N minus 1 du dx. Now, we can compare because if we use logarithmic differentiation, that's another way and maybe it will be easier for you. Okay, but both solutions will give you the same result. Now, if we're going to use logarithmic differentiation, so by logarithmic differentiation, what we do first is the first step is to take the natural logarithm, natural or ln, take the ln of both sides, and then simplify using the laws of logarithm. And then the next is to differentiate both sides. Then the fourth step is to, after differentiating both sides, is to multiply both sides of the equation by y and solve for y prime. Okay, so let's do that here. So in this example, let's rewrite the problem. We're given y is equal to x squared minus 4 raised to the 5th times x cubed minus 6x plus 1 raised to the 4th. So let's do logarithmic differentiation. So what we do is we're given y is equal to times x cubed minus 6x plus 1 to the 4th. So we take the natural logarithm of both sides. And then, after taking the natural logarithm of both sides, we simplify by using the laws of logarithm. So by the laws of logarithm, we get here ln of y. Okay. We'll have ln of y is equal to ln of x squared minus 4 to the fifth plus ln of x cubed minus 6x plus 1 raised to the fourth. Then we further simplify. So we could bring down 5 by using the law that we have what? Ln of, so by this law that ln of x to the n can be written as what? N. Okay. Ln of, what happened? Ln of x to the n is equal to n ln of x. We can bring down the exponent. So this now can be written as 5 ln of x squared minus 4 plus 4, bring this down, 4 ln of x cubed minus 5x plus 1. That's your ln of y. Now the next step is to now, since we already have simplified, so this is in the simplified form. So we now can find the derivative of both sides. So what's the first step here? Take the natural logarithm of both sides, simplify, and then differentiate both sides. So once it's simplified, we take the derivative of both sides. So what is the derivative of ln of y? So we use here the derivative of ln of, so use the derivative of ln of u is 1 over u du dx. So we have here this one, this is your u. So the derivative is 1 over y times the derivative of y, which is represented by y prime. Then on the next side, on the right side, we have here constant times ln of u. So we have a formula that we can write the constant first, and then we take the derivative of the next term. So we have 1 over x squared minus 4. We use 1 over ln of u. We use this formula. So 1 over u times the derivative of u, which is 2x, plus 4 times ln of x cubed minus 5x plus 1. I'm sorry, hold on. It should be 4 over 4 times the derivative again. We have here 4 times the derivative of this one. So 4 times 1 over x cubed minus 5x plus 1 times the derivative of x cubed minus 5x plus 1, which is 3x squared minus 5x plus 1. Okay, so actually this is the final answer, but we skip this. Let's use a different color. Okay, so what's the next step now? We have simplify muna. So we have y prime over y is equal to, take note that we have, because we can simplify the right side first before we continue multiplying both sides by y. So we can factor out here 2. Is 2 common? Yeah, it's common. We have 2 here, and then we have here 4, so this is 2 times 2. So we can factor out 2. So we have what? 2 times what? This is now 5x over x squared minus 4. X times 5. Then plus, this becomes 2. 4 becomes 2. So we'll have what? 2 times, which one? We get something wrong with this one. 3x squared this should be, I copied the other form. So this should be 3x squared minus what? 3x squared. So 1 over x cubed minus 5x plus 1. So it's 3x squared. Or it should be 6x. Oh, there's something wrong here too. Again, this should be, I did the wrong, I copied the wrong problem. So you have x cubed. This should be 6x. And then, again, this should be 6x plus 1. Okay, now 3x squared minus 6. Okay, so 4. Then ln of u is x cubed minus 6x plus 1. Then derivative of x cubed minus 6x plus 1 is 3x squared minus 6. Okay, now we factor out here 2. So, and from here, we could also factor out which one? 3 this time. So if we factor out 3, this now becomes x squared minus 2. Alright, and then divided by x cubed minus 6x plus 1. Okay, then the next step is to multiply both sides by y. So if you multiply this side by y, multiply this by y, we multiply this also by y. This is a different color. We multiply the left and right side by y. So we multiply this also by y. So when we multiply, what will happen? The result is, let's just continue on this side. When we multiply both sides by y, this now becomes what? Let's use... Okay. So we now have y prime. Now in here, y cancels with y. So the only term left on the left side is y prime. Then on the right side, we have 2 times 5x over x minus 4 plus 6 times x squared minus 2. It becomes 6 because you have 2 times 3 over x cubed minus 6x plus 1. And then we multiply by y. But what is this y equal to? Hold on. What is this y equal to? It's equal to x squared minus 4 raised to the 5th times x cubed minus 6x plus 1 raised to the 4th. So we put here x squared, we put here x squared minus 4 raised to the 5th times x cubed minus 6x plus 1 raised to the 4th. Okay, this is your y. Alright, so next is we simplify further, so we get the LCD here. So what's the LCD? X squared minus 4 times x cubed minus 6x plus 1. And then we get 5x times x cubed minus 6x plus 1 plus 6 times x squared minus 2 times x squared minus 4. Right? And then we multiply this by y. So y is x squared minus 4 raised to the 5th times x cubed minus 6x plus 1 raised to the 4th. And now you see that we can cancel one of these with x squared minus 4 in the denominator and one of these with this one. So if you further simplify, we'll get y prime is 2 times, so distribute 5x. So this becomes 5x to the 4th and then minus 30x squared plus 5x. And then we multiply these two. So here, we multiply this and this one. It gives you x to the fourth times 6, so plus 6x to the fourth. And then we multiply this to, done. We multiply, now we multiply 2x squared and this one 4x squared. So minus 2 minus 4 is minus 6 times 6 is minus 36 x squared. And then we multiply negative 2 and negative 4. It becomes positive 8 times 6. So it is positive 48. So then, we don't have the denominator anymore because we already have canceled it out. So this is equal to 2 times this one times x squared minus 4 to the fourth times x cubed minus 6x plus 1 raised to the third. So then the next is for us to combine similar terms. So we have 2 times 5x to the fourth is similar to this one. So we have 11x to the fourth, then 30x squared, and this one is negative 66x squared, and then plus 5x plus 48 multiplied by x squared minus 4 times x cubed minus 6x plus 1 raised to the third. Okay, so that's your final answer, and it's this one actually. Ito, this one here. Kaya lang, there's a mistake here. This should be 66. Okay, so we get the same answer. Okay, now we go to number 2. But before we go to let's skip number 2 and proceed with numbers 3 and 4. So what we did here in finding the derivative of this function is to use logarithmic differentiation. But as I mentioned, we can also use here these two formulas here, that we use the derivative of the product, then the derivative of u to the n, or chain rule. Now, if you're going to look at this one, we can also use the principle of logarithmic differentiation if we have this type of problem. So if you recall what we did then, so let's recall this one. We know that if we're given y is x squared, our y prime is 2x. If y is 2 to the x, our y prime is 2 to the x ln of 2 times 1. So in the first example, the base is x, or the base is a variable, and the exponent is constant. But here the base is the one which is constant and the exponent is variable. Now, how if we have y is x to the x? That's this problem here. The base, both the base and the exponents are variable. So for us to solve this kind of problem, we use logarithmic differentiation. So given this one, how do we apply logarithmic differentiation? First is that we have, look at the steps here. Take the ln of both sides. So we take the natural logarithm of both sides. So ln of y is ln of x to the x. And then the next step is for us to simplify by using the laws of logarithm. So this x here can be written here so that we have x ln of x. And then once it's simplified, No more variable exponent. The next step is for you to differentiate both sides. So, the derivative of ln of y is 1 over y times y prime. On the right side, you have x times ln of x. So what we do is we use derivative of product, u times v. So this is u and this is v. So how do we find the derivative? We copy the first, then what's the derivative of v? ln of u. So 1 over x times 1 plus copy v, which is ln of x, times the derivative of x, which is 1. And then we simplify. So we have y prime over y is equal to x cancels out. We have 1 plus ln of x. So the next step is to multiply both sides by y, because we want to find y prime. So here, y cancels with y, and we get y prime is equal to 1 plus ln of x times y. But what is your y equal to? 1 plus ln of x times y. And your y is what? X to the x. So that's your derivative. Okay? Now, let's go over number 4. Let's do number 4 here. So for number 4, we're given y is x minus 1 raised to the 2 over x. So again, the base contains, you have here the base, and this is the exponent. So the base has a variable. The exponent also has a variable. So we could not differentiate this. We need to remove this variable exponent. By what? By taking the natural logarithm of both sides and then simplifying. So if you simplify, you have ln of y equals, you can bring this down. So you'll have 2 over x times ln of x minus 1. So ln of y is 2 over x times ln of x minus 1. Let's continue on this side. So the next step after, it's a different color. The next step after this is to what? Differentiate both sides, because this is already simplified. So by differentiating both sides, we have, okay, let's rewrite it. ln of y is 2 over x times ln of x minus 1. So to differentiate both sides, we have 1 over y times the derivative of y, which is y prime. And here we use derivative of product. So we copy 2 over x. Derivative of ln of x is 1 over x minus 1 times 1. Plus, we copy ln of x minus 1 times the derivative of 2 over x. And what's the derivative of 2 over x? If we have a constant in the numerator and x in the denominator, it's what? Negative 2 over x squared. So we now have y prime over y is equal to 2 over x times x minus 1 minus 2 ln of x minus 1 over x squared. Right? 2 over x times x minus 1 minus 2 times ln of x minus 1 over x squared. Now, we can factor out here the common factor first. Simplify the right side. So what's common? 2 over x is common. We have 2 here and x in the denominator. We have here 2 and 1 here. So 2 over x is common. So we now have here 1 over x minus 1. Then minus ln of x minus 1 over x. Okay, then we now simplify. So we have y prime over y is 2 over x times, we get the least common, and the least common is x times x minus 1. So this is x, it's like cross multiplying. So x times minus x minus 1 times ln of x minus 1. And then, what do we do next? We multiply both sides by y. So if we multiply both sides by y, this cancels out. You now have y prime is equal to what? 2 over x times x minus 1 ln of x minus 1 over x times x minus 1 times y. And your y is, we started with this one. Y is x minus 1 to the 2 over x. So this is x minus 1 to the 2 over x. Okay, so we can simplify further kasi we can write this as what? 2 times what? Because we can multiply this and this one. So we have 2 times x minus 1 ln of x minus 1. Then times times x minus 1 raised to the 2 over x is square times x minus 1. So that's your y prime. We need to put here, okay, we have to put here another parenthesis. Okay, now that's what we do if we encounter a problem wherein the base has a variable and the exponent is also a variable. Okay, so look at this one. Let's do number 5. So again, here you know that we could write this as y. Okay, so the base here on this right side, the base is x. The exponent also has x. So we have a variable to a variable power. So what we do is to use logarithmic differentiation. So take the natural logarithm of both sides. So ln of y is ln of x raised to e to the x. And then we simplify. So we bring down e to the x, ln of x. And then we take this already simplified. So we now can take the natural, can differentiate both sides. So derivative of ln of y is 1 over y times y prime. On the right side, we use derivative of product. So we have what? How do we get the derivative of product? We copy the first, then multiply by the derivative of the second, plus copy the second term times the derivative of e to the x, which is e to the x, e to the u times 1. The derivative of e to the x is using e to the u du dx. Your u is x, so e to the x times the derivative of x, which is 1. And then we simplify. So this is equal to, we can get the least common. So what's the least common here? X. Because this becomes e to the x over x plus e to the x ln of x, sorry. E to the x ln of x. So e to the x over x plus e to the x ln of x. So we get the LCD. We now have, in the numerator is e to the x. It looks like you have here 1. Then plus what? X e to the x ln of x. So again, x is the LCD. So we have x e to the x ln of x. Now, the next is for us to multiply both sides by what? Okay, let's use a different color. So we multiply both sides by y. So that this cancels out. So what's left? We get what? Y prime equals what? Kasi nag-cancel na yung y. We have e to the x plus x e to the x ln of x divided by x times y. And what is your y? Y is x e to the, x raised to e to the x. Okay, this may be your answer, but we can still simplify by, because the exponent of x here in the denominator is 1. So we can further simplify by writing this as y prime is e to the x plus x e to the x ln of x times x e to the x minus 1. Because we have here the same base, the exponent here is 1, so we subtract the exponent. Okay? So, this is number 5. Then we go back to this one. For this problem here, we can apply logarithmic differentiation, or we may not apply logarithmic differentiation. Because look, if you simplify the right side, this gives you what? Ln of sine square z over cosine of z square raised to the 1/2. Then we can bring this down so that it becomes 1/2. Then ln of sine square z over cosine of z square. Right? And then you have here quotient. So we can simplify this further so that we have what? This is equal to 1/2 ln of sine square z then minus 1/2, distribute the 1/2 ln of hindi makita. Hold on. Let's just put it here. So, minus 1/2 ln of cosine of z square. Alright? So, can we still simplify? Yes, we can. Because this sine square z can be written as sine of z square. So, your y now is equal to, this becomes 1/2 times what? Ln of sine of z square. Okay, then minus 1/2 ln of cosine of z square. And so, we can bring this down again. So, when you bring it down, 1/2 times 1 times 2 is 1. So, this becomes ln of sine of z minus 1/2 ln of cosine of z square. So, if we differentiate, we can now find the derivative. So, what is your y prime? Ln of z, the derivative is 1 over sine of z times the derivative of sine, which is cosine of z times 1. Minus 1/2. Again, you have ln of this one. So, 1/2 times 1 over the cosine of z square. Derivative of cosine is negative sine of z square. Times what? The derivative of z square, which is 2z. Okay, so let's review. Ln of u, 1 over u. Derivative of sine is cosine z times 1. And then 1/2. 1 over cosine of z squared. Derivative of cosine is negative sine times the derivative of z squared, which is 2z. Now, let's continue simplifying on this side. So, we get y prime. Let's use a black color. We get y prime, therefore, is equal to, we have cosine of z over sine of z minus, now in here, 2 and 2 cancels out. So, what's left is negative times negative is now positive. It's now positive. We have positive z, because z is left. Then positive z times sine of z square over cosine of z square. And take note that cosine over sine is tangent of z, plus this is 2, this is 2. Oh, that is z pala, z. That is z. So we have here z. Again, sine over cosine is tangent of z squared. So, plus, yeah, it's positive. Okay, negative 1/2, let's check. Negative 1/2, derivative of cosine is negative, so it's positive. So this is your final answer. Okay, so we did not choose logarithmic differentiation on number 2. We can also do that. But what we did is to apply the laws of logarithm, similar to this one. Dito sa number 1, we use the laws of logarithm to simplify. Kaya lang when we proceeded to using the logarithmic differentiation. Okay, so next is we have some exercises here. So just you have to do this at home. This is an exercise for you to do at home. Now actually this is the same na nung sinolve natin. So let's put here y. And then this one too. So we're done with numbers 3 and 4. We have x minus 1 raised to the 2 over x. So you just have to do 1 and 2. And there's a solution for number 1. It's here. So you can just simply look at this one. But you solve it first and then check if you get the same answer as this solution. Alright, so the next is how we find the derivative of inverse trigonometric function. Now, this is the definition. We say that if y is a function of x determined by the relation sine of y equals x, this means that y is called the inverse sine function of x. And it can be denoted by this notation, pwede rin ganito. So, this one is shorter. Okay. So, look at this one. This is what I discussed last time. That to find the derivative of inverse trigonometric function, I write this derivative side by side with the derivative of inverse hyperbolic. We'll be discussing inverse hyperbolic in the next screen recording. So, I explained this also last time that we write them side by side so that you'll see the differences and similarities between the two. Now, we have here the formula for arc sine, arc cosine. So, we use this notation. Arc sine u, arc cosine u, and so on. Now, if you're going to look at the derivative of arc sine u, we discussed this also last time. We say that it's 1 over the square root of 1 minus u squared du dx. But for arc cosine, it's just simply the negative of the derivative of arc sine. So, sa arc tangent naman, 1 over 1 plus u squared. For arc cotangent, it's just simply the negative of the derivative of arc tangent. Same with arc secant and arc cosecant. So, this is the negative of the derivative of arc secant. Now, to make it easier for you to remember, so bali, actually, you just have to remember 3 formulas here. Now, to make it easier also, take note that for arc sine and arc cosine, you have in the denominator the square root of 1 minus u squared. But for arc secant and cosecant, it's u squared first minus 1. So then, if you have u here, you should have u here outside. So they are close together with each other. U and u are close with each other when it comes to the derivative of arc secant and arc cosecant. Alright, so then, when we go to the derivative of inverse hyperbolic, we're going to discuss the differences between the two, between inverse trigonometric and inverse hyperbolic. Okay. Also, this can simply be written as du dx over the square root of 1 minus u squared. Instead of 1 over the square root of 1 minus u squared, du dx, you could write it this way. Any will do. So for this one, this can be written as du dx over the square root of 1 minus u squared. This one is du dx over 1 plus u squared. Negative du dx over 1 plus u squared. This one too. du dx over u square root of u square minus 1. And then this is the negative of du dx over u square root of u square minus 1. Okay, so let's use these formulas now in finding the derivative of these examples here. So we have the first example is f of x is arcsine of x cubed. So here, this is your u. So again, what's the derivative of arcsine? We use what? The derivative of arcsine of u is equal to what? Du dx over the square root of 1 minus u squared. So we know that u is what? X cubed. So what's the derivative of x cubed if you follow this formula? So in the numerator, the derivative of x cubed is 3x squared. In the denominator, you have 1 minus u squared. So when you square x cubed, it is x to the 6. So we get this one. And then you simplify, you see, by rationalizing the denominator. How about arc cosine? So we know that the derivative of arc cosine is just what? The negative of the derivative of arc sine. So it's the square root of 1 minus u squared. So here, this is your u. So if u is 3x, then if we substitute it in this formula, du dx is negative. The negative of du dx, so negative 3 times the square root of 1 minus u squared. When you square 3x, it's 9x squared. Okay, now the next is the derivative of arc secant. So again, what's our formula for the derivative of arc secant? So it's what? Positive. You have du dx. Now remember, you have u outside the radical, so u squared comes first. So what is your u here? It's 2x squared. So du dx derivative of 2x squared is 4x over u squared. What is your u? Over u, what is your u? 2x squared. And when you square 2x squared, it's 4x to the 4th minus 1. So if you simplify, we cancel out 2. We cancel out 2 here. We get 2 over x squared to 4x to the 4th. And then the next one is again arc cosine. So here, we have a constant times this function. So what do we do to find the derivative? We copy the constant first. So there should be what? There should be, y prime is, there should be a 2 here. 2 times, what should be in the numerator? It's du dx. So your u is your u is this one. Square root of x. How do we find the derivative of the square root of x? Derivative of the square root of u. It's what? Du dx over 2 square root of u. So your u here is x. So the derivative of the square root of x is du dx. Derivative of x is 1 over 2 square root of u. Then over, which one? Over what? Because this is your du dx over 1 minus u square. So when you square when you square root of x, it becomes x. Okay, so actually this becomes x because you have here the square root of x is square. So when you simplify, this cancels out. And then you get, okay, let me just write it down here. Dito na lang. Medyo magulo. Kasi may sulat na. Alright. So let's do it on this side again. So, again, we're given y is 2 arc cosine of the square root of x. Okay, so what's our formula to find y prime? We copy the constant first. Now, what's the derivative of arc cosine u? we follow this formula that you have du dx in the numerator over what? Over the negative of 1 minus, because the square root of x is square. Okay, what should be in the numerator? Is what? Derivative of the square root of x, which is 1 over 2 square root of x. And this should be what? This should be negative because you have arc cosine. So we get y prime equals 2 cancels out. This cancels out. So what's left in the numerator is what? 1 over the square root of x. Then in the denominator, you have 1 minus x because the square root of x square is 1 minus x. Or the square root of x square is x. So now we have, if you simplify further, we'll have what? In the numerator, the numerator is 1 over the square root of x. Then we multiply this by the reciprocal of the denominator, which is 1 over the square root of 1 minus x. So if we simplify, y prime is now equal to negative 1 over the square root of x times the square root of 1 minus x. Okay, so that's how we get this one. Alright, and then since we have the same square root, we could combine the two under the same radical. So this is x times 1 minus x. Okay, and then we may not, because here for this one, ito yung final answer, but what's done is to multiply, distribute the x. You may not do that anymore. Distribute the x here, so it becomes x minus x squared. So you may stop at this one, but you can also what? Rationalize the denominator. Okay, so that's for number 4. Now, for number 5, we have y. Let's rewrite this. For number 5, we're given y is arc sine x. So you could write this as arc sine of x plus x square root of 1 minus x squared. So how do we differentiate this one? So we get what? Y prime. What's the derivative of arc sine of x? Here, this is u. So in the numerator, du dx. So it's 1. It's 1 over the square root of 1 minus u squared. So it's x squared. Plus, how will you solve for the derivative of x times the square root of 1 minus x squared? So we use derivative of what? Derivative of product. So we have here, this is u, this is u, and this is v. So we copy u, which is x. What's the derivative of v? We have to use here the derivative of the square root of u. Remember, it's what? Du dx over 2 square root of u. Now here your u is 1 minus x squared. So in the numerator, we'll have minus 2x over 2 square root of 1 minus x squared. Then plus, copy the second term, which is the square root of 1 minus x squared times the derivative of x, which is 1. Okay, so we can now what? We can now cancel this out. Dapat, it should be, what should it be? Negative 2x. In the numerator, you have negative 2x over 2 squared, right? Okay, so we can cancel 2. Okay, this one. And then we get what? We simplify, so y prime is 1 over the square root of 1 minus x squared minus x squared, tama ba? X squared over the square root of 1 minus x squared plus the square root of 1 minus x squared. So what's our next step? We need to find the LCD. So what's your LCD here? It's the square root of 1 minus x squared. So this is 1 minus x squared plus what? Plus 1 minus x squared. The square root of 1 minus x squared is 1 minus x squared. Okay, so square root of 1 minus x squared times the square root of 1 minus x squared is 1 minus x squared. And if we simplify, this becomes 1 minus x squared plus 1 minus x squared over the square root of 1 minus x squared. So what happened? 1 minus x squared plus 1 minus x squared. This becomes 2 minus 2 x squared over the square root of 1 minus x squared. Then 2. Now here we could factor out 2. Let's make this a little bit smaller. Right, so this is 2 minus 2x squared over the square root of 1 minus x squared. Now we factor out here 2. So this is 1 minus x squared. If we factor out 2, it's 1 minus x squared over the square root of 1 minus x squared. Then if we rationalize, can we rationalize? Let's proceed to rationalizing. So we get y prime equals what? 2 times 1 minus x squared over the square root of 1 minus x squared. If you rationalize, this now is y prime equals what? 2 times 1 minus x squared times the square root of 1 minus x squared over 1 minus x squared. And here we can cancel out this one. So what's left is y prime is 2 times the square root of 1 minus x squared. Okay, so then again I have here some exercises for you. Find the derivative of the following functions and simplify the result. There's a solution for number 1. So how do we do this one? 1/2 arcsine of 2e to the x. So this is u. Now we copy the constant, which is 1/2, this one. And then derivative of arcsine is du dx. So derivative of 2e to the x is 2e to the x times 1 over the square root of 1 minus u square. And your u square is 4e to the x. Right? Because your u is 2e to the x. When you square, it's 4e to the 2x. And then you simplify. So 2 cancels out. You get this one. Now for this one, let's do number 3. So what is f prime of x? What's the formula for the derivative of arc cotangent? So we write, we have f prime of x equals, here this is u. So write the derivative of arc cotangent. What's the derivative of arc cotangent? Derivative of arc cotangent u. That's equal to du dx over 1 plus u square. Okay, so your u is 2 over x. So what should be in the numerator? The derivative of 2 over x, which is negative 2 over x square over 1 plus u square 2 over x. 2 over x square. So that gives you minus 2 over x square over 1 plus 4 over x square. And then we get the least common in the denominator. Multiply the numerator by the reciprocal of this. So, we have negative 2 over x squared. Now, what's the reciprocal of the denominator? Get the LCD in the denominator. So, our LCD for this one is x squared. So, we'll have here x squared plus 4. Okay, so, we have here 2 over x. Okay, multiply 2 over x squared by the reciprocal of this one. And it's what? X squared over x squared plus 4. So, this cancels with x squared. Now, you have negative 2 over x squared plus 4. This is, hold on. This is your f prime of x. Okay. Now, about number 4. Number 2 muna. For number 2, okay. What is the formula for this one? What's g prime of t? Derivative of arc secant. So, what's our formula for arc secant? You have, let's write it down here. The derivative of arc secant u is equal to, alright, let's put it somewhere here. The derivative of arc secant of u is du dx over u square root of u square minus 1. So, your u is 5t. So, what is the derivative? You have 5 over u, which is 5t, times u square. So, 25, should be the square root. So, it's the square root of u square. 25t square minus 1. Okay, plus, what's the derivative of arc secant? Cosecant. It's just the negative. So, you'll have here the negative of 5 over 5t square root of 25t square minus 1. And they are exactly the same. The same but opposite in signs. 5 over 5t square root of 2 square. So, this gives you 0. Okay, for the next one, for number 4, we have, for number 4, we use here derivative of product. Okay, so, what's f prime of x? We copy the first, which is x squared. What's the derivative of arctangent? What's the formula for the derivative of arctangent? U. That's equal to du dx over 1 plus u square. So, we'll have derivative in arctangent of 3x. This is your u. So, you have here 3 over 1 plus 3x squared. Plus, we copy arctangent 3x times the derivative of x squared, which is 2x. So, this is now equal to 3x squared over 1 plus 9x squared plus 2x times arctangent of 3x. You could not multiply 2x and 3x. So, again, you use here derivative of u times v. Okay, so can we simplify further? Yes, we could. By what? Getting the least common. So, 1 plus 9x squared. Then you have here 3x squared plus 2x times 1 plus 9x squared times arctangent of 3x. Okay? Right, for the next one, for number 5, I think we can do number 5 here. Dito na lang. So, 5 is, we have y is arc secant of cosecant of 5 over x. Okay. So, what formula can you use here? Derivative of arcsecant u. And that's equal to what? Du dx over u square root of u square minus 1. So, your u here. So, what's y prime? What should be in the numerator? Now, this is u. So, in the numerator, we get the derivative of the derivative of cosecant. And what's the derivative of cosecant u? So, it's negative cosecant u, cotangent u, du dx. So, your u here is which one? 5 over x. Dito, this is your u. So, the derivative is negative cosecant of 5 over x, cotangent of 5 over x, times the derivative of 5 over x, which is what? Negative 5 over x squared. And we divide it by u. What is your u again? It's cosecant of 5 over x. Times what? The square root of u square minus 1. So, cosecant of 5 over x square minus 1. So, if you simplify further, this becomes what? Cosecant, negative times negative. So, it's what? Positive. It's positive cosecant 5 over x, cotangent 5 over x, times 5 over x squared. Okay, let's rewrite it. Let's first write 5 over x squared. Negative times negative is positive 5 over x squared times cosecant of 5 over x, cotangent of 5 over x, over yung cosecant of 5 over x, times the square root of, this becomes cosecant square of 5 over x minus 1. So, we can cancel out this and this one. So, what's left in the numerator is 5 over x squared, then cotangent of 5 over x. Tama ba? 5 over x squared, cotangent of 5 over x, divided by the square root of, okay, now, we have an identity that 1 plus, and we use the identity that 1 plus cotangent square x is cosecant square x. 1 plus cotangent square x is cosecant square x. So, if we write this as cosecant square x minus 1, that becomes cotangent square x. So, it means that this is equal to cotangent square x. So, cotangent, it becomes cotangent square of 5 over x. And when you get the square root of cotangent square, that becomes cotangent. So, this will cancel out with this one. So, what's left is 5 over, you'll have here 5 over x squared as your final answer. Okay, so we use here identities also besides using the derivative. Okay, so that ends the lesson on the derivative of inverse trigonometric function in logarithmic differentiation. Bye-bye.